Hello everybody. So the title of our article is Study of Structural Stability of a Concrete Gravity Dam Using a Reliability Approach, contributing by Mustafa Kamal Mihoubi and Mohammed Saddiq Karkar. This investigation is to establish a methodology in order to optimize the safety of a concrete gravity dam in operation by carrying out a risk analysis which includes the identification of sources of danger in terms of scenarios that can occur due to a failure on a dam-reservoir system. It is important to take account the natural ultimate case, the high floods, the earthquake, and the technical accidents such as a malfunction of spillway gate, drain valve, drainage system, or important silting. The combination between the parameter and the cases of operating mentioned above give a different scenario. This analysis technique by using a set of Algerian dams will be the subject of this context. In this computation, the random variable considered are the angle of friction and the cohesion on the one hand corresponding along the dam foundation interface. It is assumed that the uncertainty is produced by the change in the space where samples were taken and by inaccuracy relative to the laboratory during shear test. On the other hand, in the body of dam, variation of phi and c is produced by the phenomenon of a concrete degradation. It was supposed a Gaussian distribution to allow governing this physical characteristic. The probability of failure is considered as a rating on a scale. It is based on a detailed scaling and normalized to a scale of 1 to 5. In this figure, we can see the flow chart for calculating the probability of dam failure. If we consider that the probability for each scenario to happen is 1, the number of scenarios given a likely probability will be, and the ratio between this factor and the total number of scenarios is. According to this result, we can see that the ratio of the tissue half is 0.95. It is the most important among the dams today. This majority is expressed by the tip of dam, the arch gravity dam, and its stability is not only ensured by its own weight taken into calculation, but it is also ensured by the effect of transmission of a part of the force to the banks. The width of the dam is in the second place with the value of 0.91, and the Hamis dam is in the third place with a value of 0.53. These important values are caused by the degradation of the physical properties of a dam material due to the fact that the service life is considerable. Another supporting factor is the ratio, which is equal to the length of the foundation and the height of the dam. We can see as soon as this ratio tends toward 1, the dam becomes stable. Conclusion: in this work, the objective is to estimate the reliability of some Algerian concrete gravity dam during the scenarios proposed in relation to the phenomenon of sliding. The uncertain parameters that have taken are the friction angle and the cohesion, and thus are a random variable in space or in time along the dam foundation interface and in the body of the dike. Different limb combinations have been proposed which are called the failure scenarios that can encounter a dam during its service life, as shown in figure 1. The assumption it is to accept the probability of a scenario equal 1. The calculation of a probability of a failure by the three methods has given us a close and at time equal values, and the idea is to take the most unfavorable value between this method and consider it as the probability of failure to increase the safety margin.